very good morning. Welcome to Men and 5WH Tech Bytes session. In today's session, we're going to cover something very interesting called as neuromorphic computing. It's going to be the future of the AI and as well as the neurotech, which we talk about the brain-inspired computing, hardware, plastic. So we're going to really discuss something very interesting today. First of all, let's try to understand what is this neuromorphic computing. So for that, you just need to go back and see how the current world of computing is. They are all more on the CPUs and GPUs, but the way the brain works typically is quite different, right? So if you look at your human brain, the architecture is such that the processing and the memory are co-located, right? In your brain, the whole architecture is very different. So it actually happens at the same time at the same place. Okay? You're listening to a conversation and then you're able to process it, and then at the same time some part of it getting into the memory. So you can actually recall it. Okay, you can encounter different type of smells in your surrounding, able to identify which is coming from which place. Okay, all this because of your efficient processing engine which is there in your brain. So in a neuromorphic computing, you basically take inspiration from the principle of the brain and try to mimic those on the hardware utilizing knowledge from nanoelectronics and VLSI. Okay, so that is where we are exploiting the flash memory to develop vector by matrix multiplication accelerators, which can be used to process the data at the same place where it is stored. So how do we accomplish this? Basically, we need to, the processing elements, the brain on hardware and memorizer are one of the potential candidate. You need to really get that into the very deep into it. We'll have a separate session on that. You need to understand the solid state physics, circuit design and VLSI, computer science and neural networks and computational neurobiology to really mix it up to create this. Now coming back to how this will affect the normal people. Okay, today you have the entire B2B space, or do we have time for neuromorphic chips to come to the market? So if you really see, a lot of companies are already fabricating these chips. Almost all companies have a dedicated team working on neuromorphic computing. The chips are already present in some product as well as if you look at even Apple's latest iPhone, they have a chip called M1, which is an AI processor. Okay. So and similarly, you see that all sorts of applications like Alexa, Siri, they do not work without Wi-Fi. The main problem with this system is that the processing power is limited. So you can see that everywhere this technology is really ruling the world. And now to the point, like why it's so exciting to discuss neuromorphic computing. So you just look at human brain. It's the most efficient, powerful computer that exists, right? Even after multi decades of advancement, no computer can manage to beat the brain. So that is where I think the real role of these neuromorphic computing and the hardware innovation is going to really look at. And once they get into the commercial era, you can see that there are every company talking about it, right? Until recently, if you see the neuromorphic computing were widely used only in research, right? In January 18, 2022, BrainChip, a leading provider of ultra low power, high performance AI technology, commercialized this AIoT chip, which developers can use. Now, with these things happening, you can really see the future is going to be really exciting about the neuromorphic computing. So what's happening on this field? Let me give you that perspective. Intel is creating a neuromorphic AI chip that can implement spiking neural networks, SNNs. Quite recently, Intel announced the next generation of this chip called Loihi 2. You can also see Accenture, Airbus, GE and Hitachi have joined forces with the Intel neuromorphic research community. You can also see Samsung along with researchers from Harvard published a paper called Neuromorphic Electronic based on copying pasting the brain. It's very interesting. TCS has collaborated in the brain chip in 2000 for a demonstration of hand gesture recognitions. So memory MEMRYX Incorporation, a startup at University of Michigan, is developing a programmable AI exit chip. So there's so many things which is happening around life. Now let's quickly look at some of the thing like what does each of these things visualize as from a neuro. So first let's look at Wikipedia as we look at for any topic. So what it talks about, it's called neuromorphic engineering. It's also known as a neuromorphic computing, and use of very large scale integration systems containing electronic analog circuits to mimic the neurobiological architecture present in the nervous system. That's a very interesting part. So I think these are some of the questions which we normally ask, right? How much close can we reach to the brain, right? A neuromorphic computer is any device that uses physical artificial neurons made from silicon to do computations. In recent times, the term neuromorphic has been used to describe analog, digital, mixed mode, analog, digital, VLSI, and software that implements. So it's a very interesting thing for you to go through. So Wikipedia gives you a perspective about what are some of the areas where it looks at. Okay, and there is also something called memoristic systems. It's a subclass of neuroma that focus on use of memories to implement neuroplasticity. That's also an interesting area to mimicking the biological behavior, focus on abstractions, etc. So that's another area which you can look at. The next area is to really look at some of the organizations. You can see Intel is creating neuromorphic computing beyond today's AI. Okay, it's called the Lohi 2. We just discussed it, and you can see the enhancement up to 10x faster processing capability, up to 60x more interchip bandwidth, up to 1 million neurons with 15x greater resource, blah blah blah. Okay, and it's going to be really interesting to really see how these things move on in the next so many years to come. Similarly, there is a concept in human brain project called neuromorphic computing, in which they're discussing the aspects of biological neural as an analog or a digital copies on electronic circuits, right? And this white paper is also very interesting to understand. The large scale neuromorphic are based on two complementary principles called spin-maker machines and brain scales physical model, right? So that's another area which you can look at. Similarly, Accenture talks about driving AI at the edge of the neuromorphic computing. So there's a very, very interesting report you can read through, okay, which also talks about a lot of things like AI powered by brain-like computing architecture and how it really going to change the way we are looking at from an adaptive computing, right? Some startup companies which are really looking at aspects of the neuromorphic computing. If you really see the top 10 startups which are trying to work on this space. So one of the startups is in Inatera Nanosystems. It's a Dutch company, an offspring of the Delft University of Technology. It's providing the next generation neuromorphic intelligence for the sensor edge. So it can use the ultra efficient neuromorphic process, mimic the brain's mechanism for processing sensory data. It can leverage the computing capability of a spiking neural network to deliver groundbreaking cognitive performance with a narrow power envelope based on the proprietary analog mixed signal computing architecture. Very interesting aspect. Similarly, there is another startup called Koniku. It's a Nigerian startup that was first to fuse live neurons from mixed stem cell into a silicon chip. The startup merged synthetic neurobiology with traditional silicon to reach the goal of fixing urgent real world problems. This is another very interesting area. Similarly, you can see that Instar Robotics is an autonomous mobile robot maker that supplies robots for logistics and agriculture. It's useful to humans by reducing repetitive until the highlight of Instar is that startup uses neuro-inspired robots to streamline agricultural process. You have another startup called INI Labs, which incubates neuromorphic technologies. You have Nirvana currently under Intel SysSense Brain Chip is a new global technology for edge AI applications. You have GR AI Meta Labs. So many organizations who are really getting into this space. So that's a brief I wanted to talk in this session. If you have any questions, just put it on comment and discuss that in detail.